So I want to congratulate you guys on something kind of cool. Some of you may have noticed this, some of you may have not. But up until now, we've kind of been doing very basic things, right? We've been learning how to make an if statement, how do you make a for loop, how do you make a variable, right? Kind of basic things that you just basically learning the grammar of the language, the syntax of the language, and so on. At this point, you guys basically know enough to start building anything you want. You really do. You actually have enough knowledge to start building email systems, Facebook, all kinds of things. As far as programming is concerned. Now obviously there's a lot of domain knowledge, there's some knowledge of networks and so on that could be good if you knew. But at a core level, you guys basically know how to read and write. So it's up to you to now go and create poetry, if you will, right? So the first sort of introduction that I want to give you into being able to use this new set of skills that you've gained here is the ability to make games. Because games are something that we enjoy, games are something that I think are cool, and you can show it to your parents and your friends, and it's a fun way to get started, right? But I want to be clear that even though we're going to focus a little bit on games, your knowledge is not limited to games, right? You can use the exact same syntax, the ability to call functions and create variables and so on, to make all kinds of systems. And so for your project, don't feel like you're limited to only the specific use cases that I've given to you. If you want to make a game for your project, fantastic. I'd love to play your game, right? In fact, I remember teams last year, they had their sort of booth set up with the game there, and people would come and play, and if they reached a certain score, they would get a prize, like a cookie or something, you know? It was very cute. But don't feel limited to that, you know? So I know some of you are good at math. If you want to try to build a model using this, like a predictive model, I've heard someone say that, fine, that sounds great. If you want to visualize some data, and you want to do like an analytics dashboard, great, do that, right? There are all kinds of interesting things you can do with just the basic ifs and for loops and conditionals and variables that I've taught you. So really go nuts. But at the same time, understand that you have to deliver. This is, I think, key. One of the things that you guys will have learned here, I think, is how to fail. And most of you have failed quite a bit. Congratulations. It's okay to fail as long as you learn from your failures, right? If you waited until the last moment to submit your homework and then the electricity went out or you lost internet or you realized you don't know how to use Git, hopefully that taught you a lesson to not wait until the last moment. Don't repeat the mistake again. The same goes for, by the way, quick question. Can someone tell me how to get 100% on every homework? It's a simple formula. You can literally, every one of you, if you decide, get 100% on every homework assignment. Someone guess. You check? Check it before submitting, yeah. So how can you be sure that what you did, the check, is 100% correct?
To run the code.
Run the code, exactly. At a very minimum, run the code, right? Of course. If you don't, use a debugger if something doesn't work to step through the code and make sure that it works, yeah. By the way, and the things that you guys are saying are exactly what you would do if you deployed an application, right? Imagine writing some code and saying, I built the best app ever. I'm going to throw it on, you know, the App Store. And then people download your app and nothing runs. And you go, oh, sorry, I forgot to run it. You can't do that, right? Okay, so at a very minimum, whatever you write has to work. At a very minimum. And then beyond that, yeah, make it better, make it great, make it look nice, fantastic. But at least make it work. If you don't make it work, it's useless. It doesn't matter how many hours you spent on it, it doesn't matter how smart you are. If the app you wrote doesn't work, it's useless. It's that simple. Okay, so today we'll be continuing our discussion on Canvas. Now I should be clear that there are libraries for using Canvas that make it a bit easier. But in this class, I'm going to be teaching you sort of the bare bones API, the native API. Anyone want to remember what API stands for?
Application Programming Interface.
Application Programming Interface. What is an interface? Huh?
That enables us to interact with another
Yeah,
thing.
it's the medium between two things. Okay? So I want to draw things on the canvas, right? Here's me, the user. I want to draw something on the canvas. How do I draw something on the canvas? I have to call a function, right? That function that I'm using to draw a rectangle called, what was the name of the function I was using? FillRect. Yeah, you guys remember that? That is an API, right? That is a medium between me and the canvas. I use that function to tell the canvas draw, or to tell the context specifically, to draw on the canvas a rectangle, right? So the API, application programming interface, application is just a fancy word, programming because we do it using code, interface because it's the thing that allows me to communicate with the other thing, right? So FillRect is among many functions which we will look at. Another one is StrokeRect, for example, which are functions that allow me to communicate with the canvas. Got it? So it's the interface, it's the medium between me and something else. In this case, the canvas. Okay. So we talked about the FillRect function last time, and we talked about how if you want to draw a rectangle, what you need is where to draw it and how big to draw it. Fair enough. So here we say x, y, width, and height. All right. So the first two specify location, the last two specify the size of the rectangle. Fill style specifies the color of the fill. Right? So fill implies filling in, right? So FillRect means fill within this area, right? There's also StrokeRect. StrokeRect is when you don't want to fill, instead you just want to draw a border, okay? So in that case, you still specify stroke style, the color that you want to draw the border, but then if you want to specify the width of the border, you would do line width, okay? So in this case, again, we're saying use green, have, oops, sorry. We're saying use green, have the width be 8, okay, go. StrokeRect, x, y, width, and height. Now, one of the things that you might have noticed, though, is that while we have 50 by 50 here, notice how this rectangle is slightly different from this rectangle in terms of size. The reason for this is because the border width, basically what this size tells you is the size of the rectangle, and then beyond that, the border just goes out like this, in both directions, not just in. Which is why, even though both of these are 50 by 50, this one is bigger than this one. They're both 50, but the 50 ends here, and then beyond that is the border, is the thickness of the border. Make sense? Okay. So, just to quickly review how this was done, we create a canvas element. This is just an element, like a p tag or an img tag or an a tag. This whole thing is HTML. The black screen is HTML. And in my HTML, I specify a tag called canvas, a tag called script, and then code inside of the script tag, which is the code I want to run, right? In your homework, of course, instead of doing this, you do src. You do src equals blah blah, and you take all of this code, you put it into a separate file, and then you reference it from here, right? I, just to keep it simple, do it directly inside of the script tag. That's the only difference. Okay, so if that part's clear, I have an element called canvas with an ID of whatever I want. Remember, this is just a name. I can call it Bogos, Petros, it doesn't matter. So here I say, okay, document. Document refers to the actual HTML thing. Right, the tree, the actual object. And I say, hey, object, go and find the element whose ID matches whatever I give you. So here I say canvas, so it will go into HTML. Now the HTML might have other things. It might have a button. It might have, okay, stop it, okay. It might have a p tag. Right? It might have lots of other elements. So its job is to go and find the specific element whose ID matches this text. Okay? So that's what that does. Once it does that, it will return that element and put it, in this case, into this constant. What is the difference between const and let, again? Remind me?
You can change the later.
Yeah. so const means you can never change what canvas is. You can't then go and say, I want canvas to now be, a 4. Right? You cannot do that because const implies that it is immutable. It cannot be modified. Whereas if this was let, no problem. At this point, canvas has this object in it. At this point, canvas has a 4 in it. Fine. Okay. So that's the difference between let and const. Okay, so now I have this, let's change it to const. Why did I choose to use const here rather than let?
Because it's never.
Yeah, because I have no need to ever change canvas. And remember that one of the things I'm really asking you guys to do is whenever you write code and it's time to create a name, ask yourself, do you have to modify this? If you don't feel the need to ever modify it, always make it a const. Just by default, make it a const. Only change it to let if and only if you absolutely have to change it somewhere else. And by the way, there's a school of thought, there's a programming pattern called functional programming, which basically tells you never change a name, keep everything a constant. Never use let. You can actually write code, good code that works, without ever using let. I don't want to force you guys to do this just yet. This requires a bit more effort on your part, but just know that it's a thing in programming, right? There are companies, for example, that will not let their employees ever use let. Everything has to be constant. And the reason for this, again, is because if a name is constant, it's easier to understand. You don't have to read the code to understand what is the value going to be later on. You kind of know it up front.
Can I ask a question?
Yes.
So we said that you cannot use let, but how do you implement for loops in that case?
Good question. You don't use a for loop. How do you implement loops is what you're asking, not for loops. There are a few ways. One is recursion. Recursion, you can do constants and be fine with that. Recursion is kind of the main answer. The second answer is a lot of the looping you can do using some of the reserved, like for each, map, reduce. There are functions attached to arrays that you can use that don't allow, where you don't need to modify it. Anyway, so there are ways. But in worst case, sometimes, rarely, but it's like a special case and people have to come together and make sure that it's okay before, yes, occasionally you can use a for loop. It's very rare. Okay, so don't worry if you didn't understand that part. Just the core understanding here is the difference between const and a let. If you got that, let's keep going. So canvas now has whatever this returned. Now if it finds it, suppose I did this. Let me get rid of this. In this case, you're saying document, go and find the element whose ID is canvas. Do we have an element whose ID is canvas right now? No. So what it would do is it would return a thing called null, which is very similar to undefined. It just means like no, nothing. Okay, null is another way in JavaScript that means nothing. There are two ways to say it. Nothing in JavaScript. One is undefined, one is null. Don't worry about the difference. Just null means nothing. So in this case, this would return null. Therefore, the value of canvas would be null. Okay, but in this case, it has it. It finds it. And it returns an object that refers to this guy. This is a JavaScript object now. Remember, with a JavaScript object, you can refer to its attributes, its keys, by using dot notation, right? So we can do canvas dot notation, and then refer to a key called getContext. Key, attribute, they're the same thing, okay? An attribute of canvas is getContext, whose value happens to be a function. Remember that an object is nothing more than a key-value pair, right? You have a name and you have a value, a name and a value. In this case, the name is getContext, and the value is a function which takes an argument. The argument is a string. You can pass it different things. You can also pass 3D, but this is a whole different world. I'm not going to get into that. In our case, we'll pass the string 2D, okay? And what this does is it returns to you another object which gives you the API, the interface through which you can communicate with Canvas to do two-dimensional drawings. Okay? So it's the tool belt that allows you to do 2D drawings on the canvas. So you get the context here. Fine. Then we go back to Canvas and we say, hey Canvas, let me change your width key to have a value of 400. And let me change your height attribute, remember key attribute, kind of the same thing, to 300. And so that will specify the width and height of our canvas. Remember, you can think of canvas as just a piece of paper that's just drawn on the screen. That's drawn on the screen. Okay, so hopefully up until this point, it should be relatively clear. Yes? Any questions up until now? We're good. Okay. So now what we do is we say context. Remember, context is our interface to drawing to the things on the screen. We say context. Dip your what's in brush. Wow, I'm forgetting English. Dip your brush into the green ink, so it goes right. Then we say now fill a rectangle that starts at 1010 and goes 50 by 50, and it goes. And so you get. Wait, what? Oh, red. Yeah, sorry. That. Dip it in red. And then fill a rectangle 50 by 50, and we get this, right? Then we say, okay, great. Now change it, like wash it, dip it into the green ink. Oh, but line width means change your brush to a thicker brush, right? So you need a thicker brush. You dip it into green now, and you stroke rect, which means you only do the lines. You don't fill it in. You just stroke 100, x is 100. Y is 10, and then 50 by 50, which is how you get this guy here. Okay? Is this code clear to you? Yes?
I have a question. So, when you change the width and height, basically, before you changed it, it was a const or a let?
Before I change who? The canvases with the height?
Yeah.
There's no, okay, attributes of an object, like keys of an object, right now, unless you use a special thing called object freeze, which don't do that yet, you can't make it constant. Remember, there's no declaration. You just do this. Const A is an object, right, which has some key, foo, which has a value of 1. There's no way for you to make foo constant. Anyone can just do a.foo and change it to a 6. Right? Now you can use a thing called object.freeze, which freezes the object, making it immutable. But that's a separate thing we can talk about later. Yeah. Yes?
Is this like stroke rect and full rect synchronously or synchronously?
Everything is synchronous. All of this is synchronous. Okay. So, any questions regarding this code here? Does everyone understand how to draw a rectangle on the screen? Yes?
Could we please go through the last part on how it's like only colored on the...
Easy. The only difference is the name of the function. Fill rect implies draw a rectangle that is filled. That's easy. Stroke rect means draw a rectangle where you only draw the stroke. Stroke is like the perimeter. Okay? So stroke rect means draw a perimeter rectangle. Fill rect means draw a filled rectangle. That's it. The rest is the same. Location, size, boom, done. Yes?
What are that, 10, 10 or 110?
Okay, if I told you draw a rectangle on a piece of paper, what would you have to ask me? You would have to know where to draw a rectangle. You have a piece of paper, where are you going to draw it, right? You would also ask me how big. Okay? So this is the x-coordinate, this is the y-coordinate, this is the width, and this is the height.
Yeah, I understood that. So the 10, 10 means the place where I should write that.
Right. This is the location, and this is the side. These two are the sides. Cool? Is that clear? Now question. If you recall from last lecture, we have the ability to erase things. Do you guys remember the function that allows us to erase things? Clear rect. Exactly. Clear rect. Clear rect works almost exactly like fill rect. In fact, we could actually do this. We could do context.fillStyle, context.fillStyle, change it to white, and then do context.fill-rect, and erase the entire screen. 0, 0, canvas.width, canvas.height. Boom. syntax error. Like while I'm writing, it keeps running, and obviously it's a syntax error because before I complete, so it doesn't run. Anyway, so what this is doing is it's drawing a big white. Here's what I'm doing here. I'm drawing a red rectangle, then I'm drawing a green rectangle with just a border, and then on top of that, I'm drawing a big white rectangle. So obviously, all you see is big white. If I change this to black, there. Now the entire canvas is black. Right? Why? Because I started 0, 0 at the very top, and then I went the entire width of the rectangle and the entire height of the canvas, of the piece of paper, and the entire height of the canvas. Now, instead of just drawing a rectangle, I can call another API called clearRect. This will clear everything inside of this location. Now, suppose I only want to clear this guy. How would I clear only this rectangle? I can do 10, 10, and then here I can do, what was it, 50? What is going on? Let's run a programming course without any code. Okay. Were you guys around the times when the TV would stop working and you would just go poof, and then it would start working again? This might have been before your time. I don't know. I'll demo that. Oh, so good. Okay, so here we want to do clear 10 by 10 and then 50 by 50, right? 50 by 50. Okay. Notice something interesting. Listen, listen, listen. The red disappeared. Why? Because I cleared it out here. I drew it, and then I drew the green one, and then I cleared it out. If I do 25 here, I'll do 25 here, for example, boom. You guys see that? So I drew the entire thing here, and then I cleared out only the top left part of it. Okay, any questions regarding the code that you see in front of you? Is this absolutely clear to you? Yes?
Can we define width as 8 instead of pixels, but like percent? So if we change the screen resolution,
Can this be? I think you can do it with CSS. You can, but you can do. I think you can do this. Style. Yeah, but how do you do height 100%? You would need the parents to have a height, and then do it relative to that. Basically, in short, yes, you can, but I'll tell you later. Okay? Okay, but specifically, wait, before we jump into cool things, is this clear? Do you guys understand how to do this? Yes?
Can you explain the second line, where you wrote 2D?
This one. Okay, no problem. So this returns canvas, right? That part I think is clear, right? Once you have the canvas, you need a box with the brushes and the paint and all of that, right? You need a toolbox. This gives you that toolbox, but the problem is the toolbox you need to do 2D rendering is different from the toolbox you need to do 3D rendering. So the context is the toolbox. It's the box that has all your tools in it, your brush, your whatever, your paint. Once you have that, it is what you use to do things. Like you say, hey, toolbox, get me the brush, fill rect, and then it then draws on the canvas. Now you're asking, why not just do canvas.fillRect? Again, because the reason for the separation is because there's a 2D render and then there's a 3D render. And the context is what decides which one. Okay?
So it knows what to use?
Exactly, so it knows which functions to give you. FillRect doesn't exist if you did 3D. Because 3D doesn't know how to just fill rect. It knows how to fill rect with multiple dimensions, right? With 3 dimensions. Other questions or concerns? We're good? Yes?
So if we could, like, after the last line, a while that around 40 seconds, will I see all these results before the while?
No, after. Okay, good. All right, so this is clear to you then. So all of you could theoretically, right now, if I were to shut this off, take out a piece of paper and write code that creates a canvas and then draws a rectangle inside. Yes? No. Okay. If not, practice a bit and we should be good. Okay. So now that we have this, now let's do this, right? Let's create a loop for let I is 0, I is less than 10, I plus plus. Okay, so, oh, and let's get rid of this. So what have I done? Yeah, exactly. I drew a rectangle on top of itself 10 times, right? I drew a rectangle, then I drew another one, then another one, then another one, on top 10 times. That's not fun. Let's make it so that they're not on top of each other. Change the what? How can I change it? Toss plus I? Sense?
By I. Wow.
Okay, what if instead of incrementing by 1, I incremented it by plus equals 6, and then here I made it less than 100? Whee! Now instead of each time changing it by 6, let me change it by 15? 50. Okay, why do I only have 2? Because the maximum is 100, and if you add 50, after 2 times, you're done, right? So, okay, let me make it 600.
The canvas is.
Oh, the canvas is small, you're right, you're right. Oh, yeah, because I took out the canvas.width is
Does canvas have
a default, yeah, I think it has a default size. There we go. Whee! Yay! Okay. Simple, right? Easy. No problem. How do I make it so that they're only next to each other and not going down like this?
Don't change it to 6.
So what should I be? What should the y coordinate be? 0, yeah. There you go. And the opposite, if I change this to I and change this, kept this at 0, then we get them on top of each other like this. Easy, right? Is there anything about what I did here that's hard?
Can we do width and height with difference?
That question was asked. No. You can do like CSS style here, and then I think that calculates the width, and then you can use do canvas.width to do relative to your stuff. I'll give you the code to stretch it out later. Okay, so this is fine. Okay, so now what I want to do is instead of drawing, whatever x number of rectangles, instead let's do something cooler. Let's do animation. So to do animation, we need a cycle. We need a loop. An animation, what is an animation? Animation means we draw something, then we erase it, we draw it somewhere else. Then we erase it, we draw it somewhere else. Then we erase it, we draw it somewhere else. And if we keep doing this, what you should see is something like this. Right? Okay. So let's draw something on the screen. So let's go back here. And so this is something we want to draw. And let's put this into a function. So const draw. Yeah. Okay. So now we have a function that we can call that will. Sorry. Okay. There we go. So now we have a function that we can call to draw something, right? This is an example of a function that takes no argument and returns nothing. Remember, we were talking about the different kinds of functions you can have? This is a function that has no arguments, and it returns absolutely nothing. It just does something. What does it do? It draws stuff on the screen. Suppose we wanted to draw something else. We could just add it here, right? We can add a whole bunch of things that do drawing in this function.
Can I ask a question?
Yes?
Why doesn't it show undefined if it returns empty?
Because if I did, because I didn't draw what it returns. Right. D now has undefined, right? Okay, but am I drawing D anywhere? No, exactly. Okay, good. Okay, so is this obvious to you? I simply took the same code and put it into a function that I can now call. Easy, right? Yes? Good. Now, let me make it so, let me add a variable here, a let, using x delta, xd, or x delta, and have it be 0. And what we want to do is have x delta change what x is. So let's have let x be, where do we want to start x from? Let's say 10. Okay, and here we want to use x. Now if I do this, and I do draw, again, and again, and again, here's what I get. Nothing, right? What I did is I drew it on top of itself 4 times. So let me change x by this delta. So let me change the delta to 1, and let me do x is equal to x plus x delta. Notice that it's a little bigger. Why? Because I moved it. Okay, let me change the delta by 50. There we go. What have I done? And why is the first one blank? Because immediately when I come here, I change x to be 50. Actually 60, right? It starts with 10, we add 50, it becomes 60. So the first time we do something, it's at 60x, 0, 50, 50. And then after we loop again, after we call draw again, we add to that 60 another 50 and get 110. So it's 110, 0, 50, 50. Then we call draw again, and so on and so forth. And that's how we get this. Okay, let me change the delta by something bigger, like 80. There we go. Do you guys understand how this works? Look, I have 2 variables. Delta is your change. Delta is like a common term for in math, right? The delta, it's referred to as that triangle. I can call it x change if you want, x difference, x modification, x whatever. That's what this is. This is the location. I'm changing the location by the delta. And I'm rendering it at that location, going again changing x, rendering it, again changing x, rendering it. And so every time I call it, it's going to draw a box a bit more to the right. Yes?
If you wanted to start from the beginning.
Good question. You tell me, what would I do? What if you just took this?
Change and after.
Exactly. Put it here. There you go. Make sense? Because why? Because the first time x will be 10, then you change 10 to 60. And then you come here and you render at 60, then you change it to 110. And you come here and so on and so forth. Հասկացա՞ք? Բոլորը տեսնում են այս ոնց աշխատում։ Raise your hand if you do not. I love it when all of you guys know what I'm talking about. Okay, great. Okay, cool. So now, instead of just calling draw, 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 because I need some sort of a cycle. I need a loop to call draw in order to, actually, you know what? Let's make it so that every time we call it, we remove the previous one. So why don't we, every time we call it, first we do context.clear rect, and we do 0, 0, canvas.width, canvas.height. Here's what happens. Look, if I change it, here's what happens. Why do I not see all the previous renderings? Anyone know? Right, because here's what happens. The browser doesn't draw anything until our code is done. Let me say that one more time. The browser does not draw anything on the screen until our JavaScript finishes doing its work. And what is our JavaScript doing? It's clearing, drawing a rectangle, then clearing, drawing a rectangle, clearing, drawing a rectangle, clearing, drawing a rectangle. Done. Now the browser draws that rectangle. Başka soru? Դրամանակ ինքը միշտ կջնջի, երբեք եւ ոչինչ չի տեսնի։ Նայ, ես ասում եմ ջնջի, հետո նկարի, չէ՞։ Դու ասում ես նկարի, հետո ջնջի։ Եթե նկարես հետո ջնջես, միշտ ջնջած կլինի։ Չէ՞։ Եթե ասեմ ես տախտակի վրա մի հատ գիծ քաշի, հետո ջնջի իրար, տախտակի վրա ինչ է մնացել։ Ոչինչ չէ։ Իսկ եթե ասեմ եթե տախտակի վրա ինչ որ բան դնի ջնջի, հետո նոր գիծ քաշի, նոր գիծը կտեսնես։ Yeah? Okay, so this is what's happening. So what that means then is that in between these drawings, we need to wait. We need to somehow give the browser the opportunity to draw that state. So how do we do this? Well, last time I used a function called setTimeout, but this time I'm going to show you a slightly different function. It's a function that's used to do animation. It's called request animation frame. And here's how this works. Const loop is a function that will call draw. I will call loop. Any questions so far? This is clear, right? I have a function that then calls my draw function. I then call loop, goes here, calls draw, goes here, runs this. Easy. Watch this. Request animation frame loop. There we go. Now what's happening? Oh, okay. So something happened. That's what's happening. Okay. So let me explain why. Our delta is 80, right? So that means after like 4 or 5 times draw being called, you can't see box anymore because it's passed, right? So that's very fast. So let's have our delta be something very slow, like 1. Ooh, smooth. Now something that you might notice is just how beautiful that animation is. It's so smooth. It's not jittery. It just glides. The reason for this is because we use this awesome function called request animation frame. Let me explain what this does. So your browser is updating its rendering, updating what it's drawing on the screen, generally about 60 frames per second, 60 times every second, okay? So it's updating the color, see the cursor keeps going like in and out, all these things like figuring out layout, figuring out where to put things, what color they should be, all of that code is run by the browser 60 times every single second. By doing request animation frame, what we're saying is, every time you're going to do all that, first run this code. Run this code, then do that, and do that 60 times every second. Okay? Now, if our code, by the way, ran too long, like if we put a for loop here that looped over like, 10 million times and did console logs and did whatever, that would slow down our rendering. It would no longer be 60 frames per second, but it would actually go down. Why? Because we're using too much time. So you have to make sure your rendering happens quickly, so your rendering time does not go down. Another way to say this is, imagine I invited one of you up here, and I said, I want you to draw whatever you're going to draw 60 times every second. Okay, go. And you went like that, 60 times every second. Okay, so that's what's happening here. So draw is getting called 60 times every second, roughly. Okay, and every second what's happened, or every one of those times, every 15 milliseconds or so, we go here, we specify that we want to do red, we clear everything, and we draw a rectangle at whatever x happens to be at that time. We update the x with a delta, and we're done. And then again, 15 milliseconds later, the draw gets called again, and then again, and then again, and then again. Got it? So that's how you get. Whee! Okay. Cool? You change it. It's okay. So question: what should I do to make the thing go faster? Exactly. We keep changing x by 1, right? So it goes tick, 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 tick. If you want to go faster, make it go tick, 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 right? Okay, so x delta is that tick, right? So let me change it to like 5. Boom, faster, right? So let me change it back to 2, a bit slower. Let me change it to, you know what? 0.2. Yeah. Right? So all I'm changing is changing the x by 0.2. So it's going. Right? If I change it by a lot, it's going to go faster. Pause, so
Can you make that into repeat animation? Should you use while loop?
repeat which animation?
The animation that it goes then it disappears. So.
Okay. So let me ask you a slightly different question. So all of you say that you understand this code, right? More or less. We keep adding a delta, which means we keep adding a 1, which means it keeps moving to the right. Right? Every time it's going to go to the right by 1. Right? Okay. Let's make it so that when it comes and hits this wall, it goes the other way. Right, so what we have to do is we have to check if x is equal to, let's just say canvas.width, or greater than or equal to, how about that? If it's bigger than or equal to canvas.width, then what we want to do is change x delta to -1. Let's see. Wait for it. Wait for it. Wait for it. Ooh. And it just disappears, right? Because we didn't handle the case of coming back. Good question. How do we make it coming back? Okay, so one thing we could do is do another if x is what? What is this other wall? 0, right? It's the 0 axis. Okay, so if it's less than or equal to 0, then let's make sure that x delta is 1. Okay, let me change the deltas to be something bigger, so just so. Inchi dandarasa. Exactly. Good. So let me change that to -4 and +4. Wait for it. Ooh. Now question. Why does it disappear off the screen and then come back? Okay, I just heard a lot of but basically, because we're comparing the x, which is the, look. This is the canvas. This is the box. The x and y are this, right? And then the width and the height. If we compare this to this, that means this has to be here before it's less than or equal to, or greater than or equal to the size of the canvas, right? So if we want the box to stop here, we need to account for this. So if x plus, what is the width of the box? 50. And we know that. Oh, I think I made the. Oh, because it's. Wait. I think I made the canvas width big. 1 second. Let me make it 300 by 300. 1 second. Okay. There we go. Let me draw a border around the canvas just so you guys can. Oh, let me draw our background on our canvas. Okay, so ginger's head up, it comes out head over on the guy. Check context dot fill rect 0, 0. Actually, you know what? If we're drawing a background anyway, why are we clearing the background? Why don't we just draw a picture on the whole background? Won't that draw on top of everything else? Okay, so this is redundant, so we can just say fill rect but let's have the color be different, right? Otherwise, we're just going to see this. That's not great. So let's have a different color. So let's do context. Let's make a better step. Okay. There you go. You can clearly see it now. Okay, now if you guys notice something, what if we put an or here? If it's this or this, ready? Watch this, math skills, or this, and we simply did x delta equals x delta times -1. Did I just blow your mind? Askasaksha. The positive times negative becomes negative, then negative times negative becomes positive. So that's what flips it. So this x delta turns into -4, then 4, then -4, then 4. And so this is nice because now I can change the speed without changing it in 5 different places. See? I can change it to something super fast, like 25, and have it do that. Be 7. Eight. Ambos Joe. Champions, so, champions. Asa HD. Okay, good. So he's saying instead of having it just go like this, what if we had it go like this, then this, then this, then this, then this, then this? Basically follow the perimeter. I have no idea. Why don't you guys tell me? So let's start case by case, right? The first thing we want to do is it's going to start going right? So let's get rid of this. So it's good. This means it's going to start going right. So let's have this be 10, whatever. So this is what happens now. What we want is when it comes here, we want to change something. What is that something? The y, exactly. We want to start changing the y. So that means we need a y, first of all. 0. And then we need a delta for y.
Can it be the same delta? The x delta?
Yeah, but then you're going to have to figure out, watch, just the algorithm, yes you can, but then what happens if x delta is 10? You're going to have to know, do I apply x delta to y or not? Which is harder. This way, all you do is this. Look, you change x and you change y. Now, right now, y delta is 0, right? So adding a y delta to y won't change anything, right? And then we have this be y. So we just get that. Nothing changes, right? Okay, let me make it slower so you guys can see. Great. There you go. Okay. So now what we want to do is when we get to that edge, and what is the coordinate of x when it's at that edge?
-1.
Yeah, so basically what we want to do is if the y is equal to 0, that is to say the y is all the way at the top, and x plus 50 is greater than or equal to the right border, which is canvas.width. Now we want to change y, right? So we want to have we want to change y delta to be 1. So each time y is going to grow downward, but we want to stop x, right? Otherwise, you'll end up going this way. So we have to make x delta be 0. Let's see. Okay. Okay, instead of yet. You know what? Why don't we do this? Let speed be 3. And then here we can just say speed. And here we can say speed. Okay. So there we go. Good. so now we have to account for this case, right? So now we have to say if it's the case that, let's see, x is on the edge, so that's this again. And where is y? Y plus 50 is greater than or equal to canvas.height. And, okay. Y equals 0, right, we have to stop y from growing, right? So y delta becomes 0. But x delta has to become, yeah, speed times negative 1. Okay. Let's see. All right, not bad. Okay. Now, so now we need the last case, which is when the box is here, right? So how do we check if the box is here? What is the position of x when the box is here? So if եթե x-ը ավելի քիչ է կան հավասար 0-ի եւ y-ը այս չէ։ Այդ ժամանակ y-ը պետք է շուրջ տան, որ ինքը բարձրանա, բայց x-ը 0 պահենք, որպեսզի շարունակի այնքով, չէ՞։ So x delta becomes 0 and y delta becomes speed minus, it has to go negative to go up, right? So speed times negative 1. We didn't account for this one. Look, we account for 1, 2, 3, but we did not actually account for this one. So we need another if statement. That's 4 if statements. So if x is less than or equal to 0, and y is 0, right? Y is greater than or equal to 0, then we want, what do we want to do? In check was important. X delta each to thing. Nike. X6 na po. Right? X ավելի քիչ է կան հավասար 0-ի։ Y-ն փոքր է կան հավասար 0-ի։ Sorry. Ճիշտ է։ Հետո quiz-երում, I just made one small mistake. Yeah, the program broke because of the small mistake. Okay. Yay! Nothing? Okay, let's change speed to 10. Որ 500 տնենք, չես է տեսնի, որտեղ canvas-ի չափը 300 է, ինքը կթռնի 500 ու դրսի պարամետրի վրա կպստի, չես է տեսնի։ Բայց փորձենք։ Արի 200 տնեմ, էլի լավ արագա։ Yeah, it's too fast. This one? Whoa. Dude. Okay. Settle down. Alright, so one of the things that you guys have noticed about this super awesome animation that we have is we only have one box. Right? Now, a game is not that interesting if you only have like one tree or one bird or one. Imagine playing Mario and there's only like one mushroom coming. It's not fun, right? You want to have more than that, right? Okay, so you have to keep track of, for every object, listen, for every object you have to keep track of where it is, its x and y, and the direction, its deltas, right? The x delta, the y delta. So what have we learned up until now that allows us to group information into one thing? Anything? How do you group multiple pieces of information into one thing?
Array.
Array is one, good. Another one is object, good. So what we could do is, instead of decorating all this crap, we could just say const game data, make an array, and then in here put in all the objects that we want in our game. So in here we have one, okay, so we have one which has its x, which is 10, its y, which is 0, its x delta, which is speed. Actually, interesting. Let's have each thing have a different speed. So have this speed be, I don't know, 4. You know that? Now let's have the x be, x delta be 4. And then have the y delta be 0. Okay. Now in here, let's loop over this array and draw them on the screen. So here, when we do fill rect, let's instead do for let I be 0, I is less than game data.length, I plus plus. And now let's take this guy and put him in here. Okay, so in this case, const obj is game data I. Okay, so forgetting everything else, what this will do is loop over every item inside of my game data. How many items do I have inside of my game data array? One, which is this object here, right? Okay, so here's the object that I get, game data, index of I, which is 0, right? And I get back the object. Now, how do I get a reference to this x? Object.x. Remember that stuff? Kind of cool. So we can do, hang on. So here we can do obj.x, obj.y. In fact, why don't we have different objects have different sizes, right? So instead of hard coding it to 50, what if we did obj.width and width and obj.height, and we would have to, of course, add that to the object. So we would say width is 50, height is, there we go. Cool, so now we're filling a rectangle and all the information is coming from that object, right? Okay, cool. So let's get rid of this stuff for now, this logic that we wrote. And now when we, so if you notice there are two parts to it. There's the part where we render stuff. Ooh, the color. Why don't we make that dynamic too? Why don't we set color on it? Color is red. And then we have the context fill style be set right here from obj.color. Otwieram sesję. Exactly. You could just do this object dot color equals green. If if blah 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 object dot color green. Exactly. In fact, you can do it so that as it goes, it changes colors, and you get this like epileptic. Anyway, okay. So then we have to worry about the changes. So this part is the rendering part. There's a separate part which is the part that updates the data. Right? If I don't update the data, this is what I get. Why is it not moving? Can anyone tell me? Right? I am not changing any. It has an x of 10 and a y of 0, and that's it. And it just keeps drawing that. Nothing changes here. So what I need to do is do some sort of an update. It's a good idea to keep the code that draws things separately from the code that updates things. Okay? In fact, what we could do even is we can have the draw function be on the object. In other words, the object can draw itself. So we can have a draw function here. And then we can take this. Put it in here. Hima, interesting question. Watch this. This is a function that is already in the object, right? Draw is one of the keys on the object. How do we refer to the object, this object, in which this function is? My sense. Nayak, I want to access this, right? I'm in a function that is already inside of this object, right? So in order to access the function that I'm in, I say this. Yes.
Can we use it like height is this that width?
The height is this dot width.
Outside of the function.
Step? No, step just got it. Okay, so here we can do this x, this y, this width, this height. And then in here, when we loop and we get the obj, we simply do obj.draw. This part should not be a problem. I think the only thing that's new to you guys is the notion of this, right? Հայերեն բացառնամ, նայեք։ Այս օբյեկտը, որի մեջ կան անուն, արժեք, չէ՞։ Կա նաև անուն արժեք, որի արժեքը ֆունկցիա է։ Երբ որ այս ֆունկցիան աշխատում է, իր this-ը հղում է հենց այդ օբյեկտին, որի մեջ ինքը կա։ Պարզ է։ Հաջող։ Հա։ Այսինքն, երբ որ այս օբյեկտ, ասեմ, այս օբյեկտ get draw, այդ draw ֆունկցիան կաշխատի նենց, ոնց որ իր this-ը կլինի հենց այդ ֆունկցիան, այդ օբյեկտը, որի մեջ ինքը կա։ Նայեք, if I do obj.draw, this obj is the this inside of draw. Raise your hands if that's not clear to you. Okay. Look, nine. Oh, okay, fine. This is not going to be easy, but I'm going to try to do it. Here we go. Okay. This is my life. Aha. Okay. Everyone can see? Please don't post this on Facebook. I'm a professor in the UA. Right? So, this, listen. This is an object, okay? Inside this object, I have, okay. I'm inside this object. There are two things inside this object right now. Ruben and the board, right? Now, Ruben is a function. I can do things, right? Okay. When I want access to the board, I say this being the box I'm in, board. So if I want to reference this board, if you